In this example, we're going to take the try-catch block a little bit further, and instead of catching a string that we throw, this time we are going to catch essentially the result of a call to a class. So before we get into where it is that we'll see that in our rectangle.cpp and rectangle.h, I just want to draw your attention here to the fact that we have two catches. So the first statement here in our try catch block starts on 20, where we try and hope that nothing triggers the throwing of an exception. However, we do have afterwards two catches. The first catch is if there is a negative width. The second catch is if there is a negative length, because again, you cannot have a negative width or a negative length when we're talking about a real object, right? A square or a rectangle in this case. So we've got two catches here and one try. So I had mentioned it when we were talking about the chapter material, but it's worth talking about again here. Is one try can trigger multiple catches, and that's going to be okay. As a matter of fact, probably the more catches you have in a more complex piece of code, that's going to mean that you can recover from the result of numerous errors moving forward. So we've got this idea here of a negative width class object, and we're calling it E. You will notice we've got to have the 2: separator here. We do have to resolve the scope of negative width. We declare it here in our rectangle.h. So here is our class that we are going to use as a marker for our exception being thrown. So negative width is a class that is a sub portion of rectangle. So that's the reason we need that scope resolution operator there in order to point to the rectangle.h for our definition here thereof. So the other thing to notice here is I have two objects that I'm declaring here, or two classes rather, that I'm declaring here inside of my rectangle class, and one of them is a negative width, and this is what we throw if a user enters, you guessed it, a negative width. The other one is a negative length, which we throw, you guessed it, when an user enters a negative length. And essentially all we're going to do is we're going to use this to return the value. This is going to give us as developers, potentially it would give a user, if we were using it in that way, as a report for what the issue was. And again, not that different if we think all the way back to chapter 5 when we were using while loops to help catch issues like this. It's the exact same thing. These tend to be more robust, however, when we're using them in much larger program developments. So you can see, again, nothing too earth-shattering here. We have a value that we're going to return for either a negative width or a negative length. Now, one little wrinkle I'm going to suggest to you here that might help out when you are doing your own bug fixing in a larger development is counters are your friend. Don't forget about adding a static class member here for number of negative widths or number of negative lengths. I will admit to you, in this particular program, that's a really special case scenario, but somebody just can't not hit that negative number. However, when you're running on a big piece of data, you think that you have encountered all of the use cases, you think that you have figured out finally all of the probable values, all of the possible values, and you have accounted for whatever happens in the case that doesn't turn out to be the case in your data. And then you're going through and you're like, well, I don't know. I've gotten this error. I've returned, this value, but how many of them are really being counted? Just put a static class member in there for, increment it every time that negative width is called, incremented every time that negative length is called, and that helps reduce the ambiguity of you having, I've got how many of these I need to count through. Just report with your counter there instead. So if we look at rectangle.cpp, here is where we can see where we are throwing our exceptions. So there's really not much here to report. If width is greater than 0, width equals width. If not, throw negative width as an exception. So what this is doing is it is creating a negative width object of type negative width called W. That's all there is. Here in main.cpp, in our try catch block, we are catching this as a negative width object of type negative width, which remember is of type class, and we are calling it E. And here we can report on the value of our negative width object, or if we did it for length, our negative length object. Just to prove again that these will result in the program terminating like normal as opposed to instantly crashing out. I'm going to put in a width of 20 and a length of 20. That works. If we run it again, but I can't be stopped. A width of 20 and a length of negative 20. Error. Negative 20 is an invalid value for the rectangle's length. There we have it. So we can even use the creation of an object of a class in order to do the reporting on an error that we can catch and recover from.